Here we go. We're starting right now. So I'm going to start with, so good morning, everyone. So my name is Jesse, and I am with Exploring by the Seat of Your Pants. For those who don't know, we're all about bringing conservation, adventure, and science into classrooms around the world. Today is our kickoff of our World Oceans Day week-long celebration with over 50 hangouts with amazing ocean researchers and explorers from around the world. Right now, we're joined by 6 classes from across North America, so I'm going to give them a chance to do a bit of a shout-out. So we've got Miss Kingery's grade 2s from San Antonio, Texas. We've got Miss Philpott's grade 2s, also from San Antonio, Texas. All right, we've got Miss Fleur Duran's grade 7s from Estevan, Saskatchewan. Hi, guys. We've got Miss Gleason's grade 3s in Richfield, Minnesota. We've got Mrs. Krenicki's grade 6s in Colchester, Connecticut. They're just pouring in, so hi, guys. Hi. Whoa, that was way too much excitement for like 5 kids. I love it. And then we've got Mr. Gallahar's grade 2s also in, it's a San Antonio day today. We're very Texan today. It's very exciting. All right. Of course, the reason you guys are all here today is for our speaker. We're joined live by Gabby Ahmadia, who is a World Wildlife Fund lead marine scientist, which is the coolest job in the entire world. We had some fun with her slide deck getting in, so it's just going to go straight to her slides. But without further ado, thank you so much for joining us, Gabby.
Hi, everyone. Can everyone hear me, hopefully?
Yep, we're good.
All right, awesome. I wish I could show you my face, but I'm just going to show you my presentation, and then you get to see my face later. So I'm going to talk to you about my job and a little bit about what we do at the World Wildlife Fund. And I know as scientists, we like to use really big words, but I'll try to explain to you what these words actually mean. It's some of the problems we have as scientists, which we're not very good at communicating, so this is a great opportunity to get to share some of the work we do. So as you can see, I have a title. It's Conserving Our Coastal Ecosystems, and I'll explain to you what an ecosystem actually is. So I am going to just jump right into it. Can you still see the screen?
Yep, we're good.
Okay, good. Just checking on that. So my job title is a marine conservation scientist. Sometimes this actually means my parents don't know what I do. They're like, you go out and you travel and you go to places and you are doing stuff, but we don't know what that is. So I try to talk about my job in 2 ways. We kind of do science. And so this means we go out in the field and we ask questions about marine conservation. So when you hear conservation, you're like, what does that actually mean? We go out in the field and we try to protect things. You know, we protect nature, and there's all different ways you can do it. There's not just one solution or one answer. So we try to look for the best solutions in these different places to protect nature. And so some of the things we might do are ask what some of the biggest threats are. So what are the things that are actually damaging nature? That's what we want to know. And then we also use science. So we use a lot of the science that's out there to help inform conservation. There's a lot of great scientists out there already doing work, and we use this and we help inform our program people, because not everybody's actually scientists. Lots of people are actually getting out and helping work with governments and work with people to help them understand. And sometimes there's a lot of different people doing that, so we as scientists use this information to help inform this. Sometimes people think of scientists as people who sit in labs with beakers and white lab coats, but that's not actually true. You know, there's lots of scientists who do that, but there's also lots of scientists who get to spend time out in the field, I think, which is what got me excited. So if you see that top left corner, I'm actually in the darker blue shirt, and we're out in the field and we are doing surveys of reefs. And I'll tell you a little bit about my journey, and I'm happy to hear that there were some classrooms in Texas, as part of my journey was in Texas. I think sometimes when you're little, like I think when I was your age, I really actually, science was not, you know, I liked it, but I think I wanted to be an airplane captain. So I started off my dreams or my journey in Hilo, Hawaii. I grew up looking at the beach, spending lots of my free time just snorkeling around. But for me, this was fun. This wasn't actually, work. And then, after my days in Hawaii, I decided I needed to leave the islands and went off to California, where I went to undergraduate and went to college. And this is where I was, trained to be a biologist. But while I was there, I was like, Australia seems really interesting. And so I actually did a program where I got to spend 6 months in Australia. And when I was in Australia, I got to see the Great Barrier Reef, which is one of the biggest marine coral reefs systems in the world. And you can actually see the Great Barrier Reef from space. And I got to spend a lot of time out there. Then I popped over, if you look at number 4, went to Florida for a couple years, decided I should continue my education. And while I was there, I got to spend a lot of time in Indonesia, which is that number 6 that you see. Spent lots of time in coral reefs out there and decided that this was super interesting. And was like, well, I guess if I want to continue doing this and I want to be a scientist, I decided to get my PhD. And my PhD was actually out in Texas. I spent 5 years in Texas in Corpus Christi, which probably lots of you guys in San Antonio know where that is. And I did a PhD there, but I know there's a little bit of coral reefs actually off the coast of Texas. If you go pretty far offshore, there's a few little coral reefs there. But I did a lot of my work out in Indonesia and some other Pacific islands. And today I'm going to share with you 2 ecosystems I work with. Mangroves, which are those trees that you see, and coral reefs. And when I talk about an ecosystem is like almost everything you see in that photo. And so an ecosystem is the trees, it's the animals that live there, and it's kind of how they interact with one another. So you could even think of like almost your house as an ecosystem, and it's like your family or all the people and all the bugs that live in there. You guys are all one house ecosystem. And then that picture to the right is a coral reef. And you could think of the coral reef the same way. And there's fish and corals and all of those things that live with one another. They're all an ecosystem. And so I thought it'd be interesting to actually talk about what actually a coral is. You see these pretty pictures, but a lot of people don't actually know what a coral actually is. A coral is an animal, and lots of people think they're plants, but it's actually an animal. And think about it as like an upside down jellyfish. And so if you see this zoomed in picture to the left, these are the tentacles, and it's kind of like a flipped upside down jellyfish, right? And if you look to the background picture, those are all little tiny polyps. And so what you're seeing zoomed in is a polyp. And those little polyps are like a colony of animals. And so it's a colony of animals that make up a coral. What's really cool about these coral polyps is if you look at those little green dots within that polyp, those are plants that live inside of these polyps. And these are algae. And they're able to live within the coral polyp and get energy from the sun. And so the coral is like a home for the algae or the plant that lives within it. And then the plant is able to create energy for the coral. And so they have what's called a symbiotic relationship. And so going back to that word ecosystem, so coral reefs are made up of all of these corals, right? You see in that photo to the left, there's all of these different types of corals. Corals comes in all shapes and sizes. They can take hundreds of years to grow. Some grow a little faster than others, but you look at lots of different types of species. And so coral reef is this diverse underwater ecosystem that's held together by skeletons of corals. And so you saw those upside down jellyfish kind of form these skeletons and are hard. And then these become habitat to all of these marine creatures. Sometimes people think of corals as like these apartment buildings, and then the fish are all of the people that live inside them. And coral reefs are awesome because they have lots of cool creatures that live within them. And so I'm going to show you quickly a video of a octopus that I saw when I was diving on a coral reef a few months ago in Indonesia. And we're going to start it, but I'm going to go a few seconds in because it's a little bit long. But you can see this is an octopus. If you look really closely, he's camouflaged into the coral reef. And he's starting to move slowly along it. And you can see his tentacles that are reaching out. You can hear me breathing. That's my scuba equipment. And you can hear it breathing. It's hard to get rid of that noise. But this octopus, see him change colors? And then he's hunting. Oh, and he just hunted and he missed. He was hunting a lobster there. And so now he's camouflaging back into the environment, into the coral reef. And then all those fish are chasing and scavenging because they think he might have caught something. And sometimes they try to steal it. And now he's going back to the coral reef. But these are just some of the things you might see when you spend time on coral reefs, is all the different creatures that live within them. Oops, sorry. And there we go. Okay. And there's lots of words on here, but I'll explain to you what they mean. Why are coral reefs important? So this word intrinsic value. So sometimes people think, you know, maybe we save nature just because it's pretty. But we save nature for lots of different things, not just because it's pretty and you see this like pretty coral reef fish here, you know, that looks like Nemo. But they're also really important for people. And so, for example, for tourism, you know, when you go out on a tour boat, it's somebody's job, right? There's somebody who's driving the boat. There's somebody who works at the hotel. And all of this is really important for people's jobs. They're also important for coastal protection. So you guys have seen pictures of waves, or you've been out to the beach and you see all those waves. Coral reefs can actually help provide, they're like kind of like a wall against the waves. And so really important there. Fisheries, so that means a lot of fish are able to live on the reefs, and people fish these reefs, and that's important sometimes for people's protein. It's the only protein they're getting. You know, they can't just go to a grocery store. Their grocery store might be the coral reef. And also important for biodiversity. So coral reefs host a ton of species, so they have so many different species compared to lots of different ecosystems. That means that they have like tons of different types of fish, a lot of different types of coral, and that's really important for just ecosystems value. However, as you may know, there's a lot of threats to coral reefs. They're under a lot of pressure. And guess where that threat comes from? Humans. You know, stuff we do as far away in cities, and then also people that live along the coral reefs, you know, can cause a lot of pressure on them. So the biggest one right now is climate change. And so what happens when we put carbon into the atmosphere, so you look at this picture on the right, is carbon. So we are basically making the planet warmer by all of the things we do, from the cars we drive, from the electricity. It makes the earth warmer overall, and it also means the oceans are warming. And when the oceans get too hot, it's not good for the corals. If you look at this picture on the left, I know it looks a little bit brown, but that's actually a healthy live coral. Remember those little plants that I said live within that coral polyp? That gives the coral color. But when the water gets too warm, if you look at that picture on the right, those little plant or algae that live within that coral polyp leave. They're no longer happy to live. The coral is no longer a good host. And so they leave, and then they're no longer able to get energy because those plants in the polyp actually, you know, generate some energy from the sun. And so now you're just actually looking at what might turn into a dead coral reef. So the white, while it looks pretty, it's not actually a healthy coral reef. And there's a lot of other things. I'm sorry, there's a lot of words on this slide. But sometimes you fish too much on a reef. So fish can actually help keep the balance of the ecosystem. And so, you know, if your mom goes out and tells you to weed the yard, or you might be weeding the vegetables, you need to be able to control the weeds so that your flowers or your vegetables can thrive. And so fish kind of play that role as well. There's a lot of algae or plants that grow over coral reefs, but they're important for kind of weeding them. Sometimes people, destructive fishing, throw dynamite into coral reefs, and this dynamite just blasts, and it can blast 100-year-old reefs, and it's really hard to recover from it. People blast it because it's an easy way to catch fish. The sedimentation, it's a pretty big word, but this just means people are cutting down a lot of plants or forests that are maybe near rivers or coastlines, and then basically it creates a lot of dirt and like all this runoff. So things go pushed into the ocean. And then other things you may have heard of is invasive species. So there's different things such as fish species that can be really damaging for the environment. So it means that something came from another part of the world. So for example, a fish came from Indonesia and is now in the Caribbean near Florida, and it's not actually good because they're bad for the environment. So what does WWF actually do? So what is this conservation thing all about? What we do is we work with governments and we work with local communities, and we come up with solutions. We try to come up with solutions to protect the coral reefs. And we work from places as far as Madagascar in Africa to Indonesia. But it's not that easy. You know, when we do conservation, we may think it's everybody wants to conserve nature. But the truth is there's actually lots of, it's complicated because, you know, you might be telling someone to stop fishing and they've been fishing there all their life. Or we're like, oh, you shouldn't fish there. So we have to figure out the right solutions for these people. Or there might be somebody wants to develop a hotel, you know, a nice hotel on the beach, you know, really nice to go on vacation with your family, but that hotel might actually be causing a lot of damage to the coral reefs. So what does this coral reef scientist do? So what do I do to help conservation? So we might think about things where the best places to protect a coral reef. Some places are better than others. We might want to protect a healthier reef. We monitor the health of the reef. So kind of like a doctor, when you go to the doctor and they monitor your health, you know, you get a checkup. We do the same thing for coral reefs. We count the fish, we count the corals to see how many there are. And then something that's really fun is we get to work a lot with scientists in all over the world. And I'm just going to do a really quick overview of mangroves because this is something we are starting to work in. As I know, I'm coming up on my time. But mangroves are trees that live in salt water. So if you've been to Florida or even the coastlines of Texas, you see these mangroves. And they're really cool because they're trees that actually grow in salt water. And there's like 80 different types. Mangroves are muddy and crabby, so you can find these really giant mangrove crabs and live in there. You can see that picture to the right and then to the top. And these are also really important. Remember, for that coastline protection from the waves, they also host a lot of fish. People cut them down for firewood. Also, like coral reefs, under a lot of threat from climate change. And people like to grow shrimp. And they cut down the mangroves and grow shrimp. And so what are we doing? We also work with partners to conserve mangroves. So this is a pretty picture of mangroves. Again, work with communities and government. And a lot of what we do is help people protect them, but also restore them. So you can plant mangroves because they grow really fast. We use images from satellites that are orbiting above the Earth. And you can actually like map mangroves, which is pretty cool. We help work with communities to monitor their health of their mangroves. And we also try to understand this link between mangroves and people. As you can hear in this presentation, you know, conservation of nature is not just about the nature and how pretty it is. It's also really important for people. And so we like to think about both of those things when we do conservation. And so what can you do? Some of these places seem really far away, though there are mangroves in Texas, and there are some coral reefs there. But there's lots of things we do in our daily lives that can touch these ecosystems. There's things about the food that you eat. You may have heard of your carbon footprint, but maybe not. So like how much you drive, how much you use things like electricity. There's all of these things that happen in your daily life that actually can influence the outcome and health of these ecosystems. So a little things you could do in your everyday life is you can decrease food waste. So you order less food so you don't dump out half your plate of food. You can eat the leftovers in your fridge. You can learn more about the food that you eat and how it impacts the environment. So this could be a cool project that you could work on. There's lots of interesting things to read out there. And you can use less plastic. So instead of buying a plastic water bottle, which just can often go straight into the ocean, you can get a reusable water bottle that you use every day. Or use a reusable shopping bag. And then the last slide is, there is actually, WWF has produced a lot of material, and you can learn more about oceans conservation at wildclassroom.org, and happy to share that later on. But there's lots of material on there which you can learn more about the oceans. All right, and that is it from me. And now it's time for questions, and I'm gonna switch it to my video.
Yeah, you're good. We've got you live now.
Am I on video?
You've got your face.
Okay, great.
All right. Thanks, Gabby. And I'll pass on the Wild Classroom link to all the classes at the end when we're done, too.
Perfect.
All right, guys. Quick note before we go to the classes. We've got a bunch of groups watching online as well. If you're watching on YouTube, you can send in questions in the little chat bar on the right, and I can pass them on, just so you know. All right, but we'll start with Miss Kingery's class. If you guys have a question, come on up.
Sorry. No? Nobody has questions? Hey, Jace, come here. Ready? Walk. Okay, come up and ask a question.
How does the system work about the WWF?
As what system?
Oh, could you repeat that really quick? Sorry.
How does your program work in the WWF?
How did your program work?
Huh?
How does my program work? Okay, I can tell you a little bit about WWF. So if you saw the logo, sometimes people see the panda and people think all we do is protect pandas. But actually, you see I work for WWF and we actually protect oceans. So we protect oceans, we protect forests, we protect water, we work on climate change, we work on all kinds of things, and we have offices all over the world and, save elephants and rhinoceroses and everything. I don't even know if I said that right. I'm a marine scientist, so I say the animals wrong sometimes. The land animals, I don't know them as well. Ask me any questions about fish and I can answer any question. But yeah, we do lots of different things.
Excellent.
That answers your question.
Hope so. All right. Well, we can revisit it when we get back to that class. But for now, we'll go to Miss Philpott's class.
Okay.
You guys have a question?
What does WWF stand for?
That's a good question. I did not say that. It stands for the World Wildlife Fund. I don't actually think the name is great because we work on lots of different things, as I just said, but World Wildlife Fund.
Excellent. All right, Mrs. Pleur Duran's class. If you guys have a question, let's.
How deep is the water where coral grows or lives?
Oh, great question. So most of the corals I study are pretty shallow. So if you think, I'm trying to think about a tall building, maybe we go about 60, 70 meters, 60 feet deep. So maybe like a 2 or 3 story building. That's about how deep you go underwater to look at the coral reefs, because remember they need sunlight. But what's interesting is there are some coral reefs that are deep that don't need sunlight, but they grow really slow and they're not like all the pictures that I showed you. So those are pretty shallow.
Excellent. All right, and we'll go to Ms. Gleason's class.
Go ahead. Yeah. Can you have fun monitoring coral reefs?
Can you have fun?
like with the
So much
animals.
fun. I wish I had time to show you a video, but what we actually do is we scuba dive. And so we put on our mask, we put on our tanks, and we lay these big measuring tapes. And then we get to spend so much time underwater and just counting fish and counting corals. And it's so pretty and it's so fun. I feel really lucky that we get to do that.
So it's just the most fun is the answer.
It's the most fun.
Perfect.
Yeah.
All right. So we'll go back through all the classes. We got time for several rounds. So Miss Kingree's class, come on back up again if you have second student.
How does coral reef get its name?
Ooh, that's a tough one. I'm not sure what the word coral actually came from. They call it coral reef because a reef is like a structure. And it's a coral reef because it's mostly made of coral, the animal I showed you. But you can have other types of reefs like oyster reefs, rocky reefs, reefs made of rock. But a coral reef is because it's made from corals.
Good question, though. That was a nice trick.
That was a tough one.
I like it. All right, Miss Philbot.
Yes, we wanted to know how the trees actually grow in the mangroves. They were in the water. They were all confused.
Yeah, no, mangroves are really interesting because their roots actually go down into the mud and into they go down, they have roots like this and they stick down into the mud. And so they just grow a little bit differently. So they have these really big clawed out root systems. So they sit on top of them. And so it's basically like a tree, but just you see a little bit more underwater. That makes sense.
This is a good reminder for people that might be watching online that they can write in questions. So Mrs. Kranicki's class asks, what did you study in high school and college to get so interested in coral reefs?
Oh, that's a good question. So I mostly studied biology. I will say there's going to be a lot of people in life that are going to tell you that you can't actually do what you want. I remember getting told in college, I wanted to study coral reefs, and somebody who I really liked told me that there was no job in it and that I couldn't do it and that I was just trying to save the world and that it was unrealistic. And so I also want to tell you, if you're really passionate about something, you can just go for it and do it. And so what happened was I actually was like, maybe I can't do this. And so I studied more general about animals. I had a more general degree and I studied. And then when I went to Australia, I was like, I love this. And so I decided to continue to work on coral reefs and realized that I could do this if I wanted to.
Outstanding. It's one of the most common themes we get is people tell you that you can't do something. I bet that person doesn't get Christmas cards anymore from you.
No.
All right. We did have a question from another class in San Antonio. I think all of San Antonio has come out to hear your presentation today. So Miss Brown's class asked, what are some of the things you do that your parents don't understand?
Well, I travel a lot. And I go to lots of different places. And I think sometimes they think I spend a lot of time underwater or I do the monitoring, which somebody asked about earlier, and I'm counting fish and counting corals. But a lot of what I do is going to meetings and working with people and working with other scientists or sharing my science. And, sometimes it's a little bit hard to explain all of those pieces that you're doing because when you're a scientist, you do lots of different things. I also do a lot of data analysis, which is cool. I really like numbers and I like data. And what's helping is something that's really interesting now that's helping scientists is learning how to code. And so now we have to learn how to code when we do all of our math. And so we use coding and we do all of that fun stuff. And so trying to explain coding or working on computers to your parents who grew up in a different generation, they don't always understand.
Excellent. Great answer. All right, let's go back to Mrs. Plura Durant's class. And whenever the mic demuting works, it doesn't want to work. There we go. Good. Oh, it muted again somehow. I don't know sorry. Let's try this again. Maybe.
What can we do as a tourist when visiting these ecosystems?
Excellent.
Good question. So one of the things you can do is try to be a responsible tourist, which means looking, maybe when you go on a tour, there's tours that might be eco-friendly, and that means that they might be taking practices or doing things that might be more friendly to the environment. So for example, if you go snorkeling on a coral reef, you want to make sure you don't kick the coral. And that means you should be given a life jacket and be given proper fins, and you stay far away from the coral so you don't kick them, because they can be hundreds of years old and you kick down a 100-year-old animal. And now you know they're animals, and so you have to be even more careful. And not using as much plastic. That's a big one. People love to give plastic on airplanes, on boats, and everything, and it's just becoming a big mess in the oceans. And you see whales are eating plastic, turtles eat plastics. It's really horrible.
Great question, great answer. I've been saying this in my other hangouts for World Oceans Day week. National Geographic just released a whole issue on plastic pollution, and there's tons of things that kids and people can do that are really easy and painless to curb plastic waste. So I'll send that at the end as well.
Yes.
But first, we'll go back to Miss Gleason's class. You have another question?
Go ahead.
Good, yeah.
Go ahead.
We've been learning about inventions that help coral reef. What inventions do you guys think help coral reef the most?
I didn't quite get the end of your question. Can you ask again?
We've been learning about what helps coral reefs. Inventions that help coral reefs. What inventions do really help coral reefs?
What inventions?
What invention?
Help with pollution.
Oh.
To help with pollution inventions, we've been learning about inventions that help with pollution and like clean up the ocean water, and then also instead of water bottles, like those drops of water.
Yeah.
It's water
bubble that you can eat.
Ooh.
Whoa. I have not heard of this, but that sounds really cool. People are thinking a lot about this and thinking about technology and how can technology help with coral reefs. But some of these things are just simple solutions. Sometimes we like to make things really complicated. And I heard a really interesting talk from somebody from India last week. And he said, technology, we don't always want technology. We just need basically boots on the ground. He said, we need money for fuel for our boats, so our boats can go out and patrol the reefs, right? Sometimes we don't even have those basic things. And so, like a police car needs gas. And so you can have the police car that goes around the city. You actually need fuel for your police car, right? You go to the gas station. Sometimes a lot of our rangers that patrol these reefs don't actually have enough fuel. And so sometimes it's thinking about some really simple solutions that can help conserve reefs is, having enough resources to basically fill up your patrol boat.
And they're usually cheaper too, the simple solutions.
Yes.
Excellent. Gabby, do you have time for one more round of questions?
Yep, I do.
Perfect. All right. Well, let's go back to Miss Kingery's class then.
How did the fish get their name?
How did the fish get their name? This is a good one because I used to study this a little bit. So I used to work on, I've described a fish species, which is cool, out in French Polynesia, which is in the middle of the Pacific Islands. And there are lots of rules about naming fish. So people, there's just lots of rules about them. You actually don't really, it's kind of boring, so you don't actually want to know. But you have a Latin name, so it's in one language that people use to describe species. But then the fun part is you get to give it a common name. And so you might have some like boring fish name, such as, I don't know, I'm not going to tell you. But then you get to give it a fun name as well. And so sometimes people just give a fish a name based on what it looks like or a color, or they might name it after someone. And there's lots of different ways people name fish.
Awesome. Really quick. Oh, they just left. I was going to see if Miss Gleason's class had another question. They had to go a little early, but that was great. Yeah. Okay, we'll do Miss Philpott's class.
Why do sea animals live in salt water?
Why do animals live in salt water?
Yeah.
Okay, lots of different animals live in saltwater. Lots of them, they're adapted to it. So we like to live on land, and that's how our bodies, you know, we're able to use energy and we're able to breathe. And there's some animals that are adapted for the sea. And yes.
So different strokes for different folks.
Yes.
All right. Let's finish off with the last question by Mrs. Fleur Duran's class. If you guys want to come up and there we go. The mic's good. You're good.
Where do you most often find the mangroves?
The mangroves?
Yeah.
That's a good question. So mangroves in the US, you'll see them in Florida. If you go down to the Everglades, you'll see a lot of mangroves. If any of you have been lucky enough to go there. And in Texas, I know we had a lot of Texas classrooms, you'll see them along the coast. And you'll just see trees. If you see trees that are actually living like in the ocean or living with a lot of salt water around them, it's probably a mangrove. But they're all over the world in warm water. And so all over Indonesia, the Philippines, and the coastlines of Africa, in India, mangroves are everywhere.
Very diverse. Are they always saltwater?
Yes.
Okay. All right. Well, guys, that was wonderful. So what we do at the end of every hangout is I'm going to demute every class's microphone. So if you guys want to join me, so Ms. Kingery, Ms. Stillblatt, Ms. Fleur Duran, I'm just saying a big thank you to Dr. Gabby for joining us today. So thank you.
Thank you.
Awesome. Dr. Gabby, that was wonderful. Thanks so much for joining us.
Thank you. That was really fun and great questions. It was really nice to see all of you guys today.
Yeah, well, you're welcome back anytime. We're going to pass along the wild classroom to all the classes at the end. And for the class, if you guys are joining us for the rest of the week, again, we've got 50 hangouts this week with ocean researchers from around the world. So we're really excited to highlight World Oceans Day. And thanks so much for joining us today, guys.